All right, so we are doing our warm-up right now. We are on formative, and formative is asking us, what are some possible units? I'm gonna give you one more minute. Let me look at the totals. Alyssa, looks like you still need to open it. Fateh, Izzy. And then we should have number 1. We're filling in number 1. Alyssa, yes. Izzy, make sure you open up this formative, please. All right, so let's take a look here. We are being asked possible units, or what you guys sometimes call labels, for time, distance, etc. So volunteers, let's start with time. Just give me one possible unit for time. Derek, give me one, please.
One possible unit for time is minutes.
Thank you. Donovan?
Another possible unit for time is seconds.
Thank you. Matthew?
Another unit is hours.
Thank you. Faith?
I was gonna say hours. That's
Okay. Fateh? Oop, you just put your hand down.
Another unit is microseconds.
Oh, microseconds. Yep. Armand?
Centuries.
Okay. Adi?
decades.
Decades. Good. All of those are possible. I'm looking at your formative and I see seconds, minutes. Some of you put T. Be careful. That's a symbol for time, not a unit for time. Seconds, minutes, hours, days. Okay. So go back and fix it. Again, when we're doing this formative, you want to go back and input the correct information as we're going through here. Okay. Then we have distance. What are some? Let me clear your hands. Go ahead and re-raise your hand if I deleted you. Brianna, what's a unit for distance?
Meters.
Meters is a possibility. Good. Garika?
Yards.
Yards. Okay. Rihan?
Feet.
Feet could be possible. Marcus?
Miles.
Miles. Good. Fateh?
Inches.
Inches. All right. All right. So those are good. I'm looking at your formative. Meters, feet. Some of you put the letter D. Fix that. D is just the symbol. It's not the unit. Miles would work. Meters would work. Centimeters. Good. Okay. Some of you are giving me the equation. That's not what I want. I want possible units. Okay. Now, when it comes to speed, speed is going to be distance over time. So One possibility could be, let me show you, let me take these names off. One possibility for speed could be miles per hour. Let me scroll up. We could have miles per hour as a possibility. Matthew, what else?
Oh, I was gonna say miles per hour.
Okay. Let me clear the hands real quick. Anybody else have another possibility for speed? Let me scroll through here. A lot of you said miles per hour. That's what we're used to seeing in our cars. Armand?
Meters per second.
There we go. We have another one here that says meters per second. Okay. Now, velocity is the exact same thing as speed, but there's only one little difference. Who can tell me what's that difference? Velocity and speed are the same thing, except for one little detail. Sahil, what's that detail?
Direction.
Very good, direction. So like we see this student here, they put meters per second and then they added south to it. So we need the direction it's going in. So I'm looking at what you guys wrote over here. A lot of you left it blank. We want to add on there. Here we go. The student put miles per hour east. Good. So we have the speed with direction for this one here. All right. Acceleration. This was the extra credit of your quiz. Anybody remember what the units for acceleration are most commonly for this one here? Trying to give one more moment, see anybody else. All right, Sahil, do you remember what are the units?
Any unit of distance over any unit of time squared.
Okay, so the most common one is going to be
Meter per second squared.
meters per second squared, like this one here. Okay, and that's the most common you're going to see in physics. And then last but not least, we have our units for force. Who knows what we use for force? Garika, what are the units for force we usually use?
Newtons.
Okay, so we have the Newton or the capital N, okay? So go ahead, make sure you have these in your arsenal. Hint, wink, wink, you're gonna want to know these for your final exam, okay? What we don't want, this is, for instance, some of you gave me the symbols. This is not what we need to know. What we need to know are the units, possible units, hours, meters, etc. for this one here, okay? So go back and fix those if you haven't already. And today is all about review, okay? I'm gonna go through these slides one last time. If you have any questions, please, please, please stop me and clarify. And then I'm gonna let you go through your exam review worksheet, okay? So motion. Motion is when an object's position changes over time. You can even say it's when the object's distance changes over time. You can calculate the speed of that object if you know the distance it traveled and how much time it took to get there. Now, today you're going to practice these again because I know a lot of you were worried about this last week. We're going to practice calculating distance and time and making sure we understand what units, what equation, etc. today, okay? We know that velocity and speed are the exact same thing, except velocity has direction with it. And if that velocity changes in any way, then we are accelerating. And accelerating could be speeding up, could be slowing down, or changing direction. You're going to see some graphs today in our review, and you need to pay attention to what they are measuring. Is it position? Is it velocity? Or is it acceleration versus time? Because those lines means different things, okay? We know Newton's first law has to do with an object being in motion or an object being at rest, and that not changing unless you have an unbalanced force. We also know that resistance to change in your motion is inertia. And inertia is going to be affected by the mass here. Armand, is that a question? No. Okay, moving on. Then we know forces. We just reviewed that the unit for force is the Newton. And then we have a push or pull for this one here. Okay, never mind. Then we have balanced versus unbalanced forces. And we know if it's balanced, they are equal in opposite directions here. They will not affect the acceleration of the object. However, if they're unbalanced, they are unequal and they will cause the object to accelerate. We also know that all forces have both magnitude and direction because they are a vector quantity. Net force, you're going to practice this today. If they're going in the same direction, we're going to add them. If they're going in opposite directions, we're going to subtract them. Okay. We know second law. I apologize. I don't know why that shopping cart keeps disappearing. I'm going to add that right now. We know it has to do with the force, the mass, and the acceleration. I'm going to add the equation up here as well. F equals ma. And so the more mass an object has, the less it's going to accelerate. And the less force it has, the less it's going to accelerate as well. So we can see how these guys are all related. Last but not least, Newton's third law of motion states that when there's an action force, there's an equal and opposite reaction force occurring in the object. If the motion is not changing, then it is equal. If it is changing though, then we know it is an unequal system for this one here. All right, questions? All right, so now we're gonna go back in our breakout rooms and I want you to help each other going on working through these problems. You don't have to stay together, but I do want you to double check with each other. So if you're like working on your own and you finish number 4, then you can check with your group, hey, what did you guys get for number 4? And double check each other and make sure, answer questions, ask questions as you go through this exam review worksheet, okay? So I do want you to talk to each other. I'm popping into the rooms and the teams that are actually talking to each other are actually progressing through the worksheet a lot faster than those that don't. So please talk to each other. Show me with your fingers though, how many people do you think work best in a group? Do you think pairs? So give me 2 if it's a pair, groups of 3. Do you like groups of 4? So show me with your fingers how many people you like to have in your group. A lot of you are not voting. Fingers, fingers. I see a lot of 4s, a lot of 4s, 2, 3s.
It depends on who's in the group.
Okay, well, it's random. It's a random pick in the way the Zoom goes. So I hear, okay, let's do groups of 3 for now. We have 30 students, so I'll have 10 people. So what you're going to do is you're going to go ahead and work as a team. You can go ahead of each other. You don't have to stay together, but I do want you to double check all your answers with each other. Let me stop sharing. And let me create these breakout rooms easier. We're gonna have 3 people in each room. Create, and I need to make sure I am in one of these. And let me just scan through here real quick. right. Have fun, you guys. Oh, let me pause recording.